We have talked about seasonal decomposition, and structural time series is a very similar concept. The seasonal decomposition was decomposing into trend and seasonality. Structural time series is an open-ended decomposition, so we can decompose it into many terms. Imagine that this is our time series. A structural time series is the decomposition in the trend, which is the growth in the data. Next, we have the seasonality. For instance, ice cream is a seasonal type of product since it peaks in certain periods. And then finally, we also have exogenous impacts which affect our time series, like the weather, marketing investments, economic sentiment, and so on. The secret to a good forecast is actually determining which exogenous variables we should use in order to continue to explore what affects our time series. Nonetheless, error is indeed part of forecasting, so this is something that we also should accept. To recap, structural time series can be decomposed into at least, and at least being the important thing, trend, seasonality, exogenous impacts, and then finally the error term. From a mathematical perspective, this is how we put it into an equation. So we just add. In case that we have multiplicative, then we multiply the factors. This is also an important thing. After understanding what structural time series is, then let's look at Facebook profit. And it's super simple. Let's start with some curiosities. It was built by Facebook, which is now called Meta, but honestly, and this is one thing, so everyone still Googles like Facebook profit, never Meta profit. Though I think Meta profit kind of like has a nice ring to it, but nonetheless. Next up, it has this Stan background, so this causal or Bayesian inference kind of probabilistic background that is done in order to involve our algorithm for the computations. Stan is not really well known, but those who do, they're actually huge fans of the topic. On the third fact, we have the dynamic holidays, which is this different events over time. For instance, the impact that Christmas Eve may have on the time series may be different from the Christmas Day itself, and this is super important. Additionally, we can customize it in a way that it is simple, so it's not ultra complex. And then as well, we have this built-in cross-validation, which is very important, particularly for time series, to understand how our model actually behaves in different periods of the year or of the week. To sum it up, it brings a lot to the table, and it also means that there's a lot to learn. The last thing that I want to cover is actually the methodological framework. We have this equation. So we do have the trend, seasonality, we have the holidays, and we have the external regressors. And the way that we look at it, so trend is the growth, and I'm using here the plus, but in case we are using a multiplicative model, then of course it is times. We have the trend, seasonality, and then we have the holiday effects, and we have the external regressors, and then finally, we always have the error. The last thing that I want to mention is that you can have holidays that are included as external regressors. So it's really up to you to figure out how to actually do it. We'll cover both scenarios where we have events or holidays, and we also have the events as external regressors. We'll cover it. It will be crystal clear during our practice tutorials. And this is actually what I want to kick off in the next video. Until then, have fun.